So 1 through 5, the answer, I already posted the answer key way back when. So let's go to 6 and 7, which I hadn't really covered yet when you were preparing for the quiz. Okay, so we're supposed to predict the number of solutions, justify your answer. Okay, somewhere in the over here, somewhere here, I will say if lines cross, right? If lines cross like that, and let's say this is y1, right, and this is y2, so there your two lines like that. There's a POI right there. There's a point of intersection. So the slope of the first one is not going to be equal to the slope of the second one. That's all we need to watch out for there. Okay. And then we have a little chart here where we have this other scenario. Doesn't matter if they both are going up or down, right? So one solution. Right? If you have one solution, all we need to watch out for is that the slopes are different. Who cares about the y-intercept? Okay. And no solution. When do we know that there would be no solutions, right? When the slope of the first one, so let's call this y1 and y2, just to say that those are two different lines, right? If the first slope is equal to the second slope, right? You are in this territory of no solution, but you got to make sure that the intercepts are not the same. Okay, so then you know this system, because we're talking about two equations, will have no solutions. They're two separate lines that run alongside each other. They will never meet. Okay, and then you have infinite. That's when the lines coincide, and basically you have y1 and y2, they're both one line, right? And so we know that, first of all, their slopes will be the same, and their intercepts will also be the same. Okay, so this is your little legend, other than the one I already gave you, where you can tell what's happening here. So if slopes are different, forget about the y-intercept, you're done. You can conclude one solution. If the slopes are the same, then you have to narrow it down, right? Because it could be no solution or infinite number of solutions. And that you do by comparing the y-intercepts. Okay? So that's how you just think about it in those terms, and then you will know what to do. I would always suggest to rewrite into slope intercept, and then you make your decision based on that. That's what I would suggest. Okay, because some of us will mix up general with standard form, and then it gets you off track. Like you will get the wrong y-intercept by using the shortcuts that I've shown you in chapter 6. Okay. All right. So let's go over here. We're asked to predict the number of solutions, justify your answer. And maybe what I will do is I'll just do it on the side here. So A, we have the same slopes, right? So we can call this 1 and 2 like that. First equation, second equation. We make an observation that the slopes are the same, but the intercepts are not the same. See, they're not the same. So we are in this category, okay? No solution. Parallel lines. See how easy it is? B. Let's call this 1 and 2. And there I'm going to be in trouble because I will run out of room most likely. So I won't be able to fit C in here. We'll do C somewhere else, okay? But for B, maybe I will right away say I'm not going to do B over here because I'm going to run out of room. I have to rewrite. So I will do 6A somewhere over here. 6B, I apologize. So 6B is done here. This is 6A, and 6B is down on the side here. So rewrite. So I will go, you got to be careful. I don't know, I still see a lot of small mistakes that throw everything off. So maybe you are the person that needs to make sure you don't do too much in your head and skip steps. You actually have to show line after line. Will it take a little longer? Yes, but it will pay off. So let's copy that down and rewrite. So the 2y stays, the x comes over, subtracting, the 7 is already there. Okay, divide everything by 2, positive 2 that is, and please don't forget that it affects both. Okay, so that's negative 1 over 2x plus 7 over 2. No decimals, okay, reduced fractions only. So this is the first one, and then 5x plus 10y is equal to 35. Then we'll move stuff over. So 10y is equal to negative 5x. Right, the 5 comes over, subtracting, and the 35 is there. You divide by 10. The whole thing is divided by 10 on both sides. Y is equal to, this reduces to negative 1/2 x, right? Plus 35 over 10 can be reduced to, right? The 5 goes in there 7 times. The 5 goes in there 2 times. So when you reduce them both, right, we can call this now 1, 2 like this, right? We will say that slope of the first one is equal to slope of the second one, and their y-intercepts are also the same. Therefore, infinite number of solutions coinciding lines. Okay. So you've looked at their slopes, you looked at their y-intercepts, you're done. I will also say this though, let's backtrack because this is the fail-safe method. You can't go wrong unless you make a mistake, of course. Let's go back to the top. Notice that to get from 1 to 2, you could have multiplied every single term in the first equation by 5. If you multiply that by 5, you get exactly the second one. So x times 5 is 5x, 2y times 5 is 10y, 7 times 5 is 35. If you notice that, like if you say that the first equation has been multiplied by 5 by a constant to get the second one, there's a pattern. Therefore, there will be an infinite number of solutions because really the equation is the same. You're talking about the same equation. Remember, when we're doing elimination, substitution, whatever we do, when we multiply the whole thing by a constant, you come up with a different one that looks different, but it's really the same line. Okay, so either way, I'm fine with it, but this is the one that I would suggest so that it's easy to see. Boom, right? You got it. Okay. C I will do over here. Slopes they're both rewritten already. So slope of the first one is not equal to the slope of the second one. They're not the same. Okay. So in that case, right away you can conclude you don't have to look at the y-intercepts, even though they are the same, right? you're done. One solution. One solution. That's it. That's all you have to say. Boom. They share the y-intercept, but they're different equations, but they will be meeting at that y-intercept. That, yes, that is true. And that will be the solution to this particular system. But there's only one solution here. Okay? Capiche? Wakey, wakey. All right, I haven't done attendance yet. I know that. I'm just more interested right now in getting this done and be able to make sure you understand before the test. Okay. All right. So this is where you compare and you analyze and you make your decision. Right. You make a conclusion and follow. Watch the steps that I'm taking. Right. I compare the slopes. I compare the y-intercepts, and then it's right. I don't compare the y-intercepts when they're different, and I'm done. I don't need to go over because even if they are the same, it doesn't change anything. But if the slopes are the same, you need to go one step further and look at the y-intercepts. Right? Okay, we are now given a system, right? So we're given, an equation, 2x minus 3y is equal to 8. Write a second equation so that the linear system will have no solution, one solution, infinite number of solutions. Okay, and I would like to write them in both slope-intercept and general form, just so we practice going back and forth. So grab a piece of loose leaf, or you can do it on the previous page. How about that? There's a blank page right here. So I will do chapter 7 review. We'll do 7. We are given, I will rewrite this quickly, 2x minus 3y is equal to 8. And can I please make sure you understand, read the equations carefully, right? Like if I flip the x and the y, we're so used to always x then y, but look at them carefully, right? How do you go about it, okay? So write a system. And the first one is no solution. i.e., what do we need? We need the slope of the first one to be equal to the slope of the second one. And we need the slope of the intercept of the first one not to be equal to the slope of the second one, because we want two separate lines that run parallel. That's what we want. That's why this is right, parallel lines. That's really what we're after. Okay, so let's take the first one. So 2x minus 3y is equal to 8. I will rewrite it, and I'll just go arrow, not equal sign, and the negative 3y stays. The 2x comes over, so it's negative 2x plus 8. Then I divide everything by negative 3. Arrow. This is positive y, right? And you have positive 2/3, because negative and negative, right? And this is negative 8/3, like that. So this is my first, I'm going to just go by this. This is my first equation here. Okay. I'm going to write a second equation. And that will be y is equal to 2/3 x. Okay. And just write a different y-intercept. You can go minus 9/3 if you want. Okay. So you look at the y, they're different, right? Different y-intercept. Okay, Jan. We're looking over chapter 7 review. We're actually doing question 7, where we write systems, okay? So just go back to the back of your booklet. So there you're done. But let's continue. Write them both in general form. So write both in general form. What if I ask that? So this is an extension. I understand that. Okay, it's an extension. So what if I asked you to do that? So because I went from this is the standard form to the y-intercept, I will just take this one as my first, right? So I will just go 2x minus 3y, and the 8 will come over, minus 8 is equal to 0. So that's this one right here. I just took advantage of that. It was almost in general form, just brought the 8 over, and it's equal to 0. You're done now. And then the second one, I'm going to go y is equal to 2/3 x minus 9/3, like that. And I'm going to just manipulate this whole thing. I'm going to say that I'm going to multiply by 3. In this case, it makes sense to multiply everything by 3 because we don't want fractions, right? So that gives you 3y is equal to 2x minus 9, like that. That is equal to, I'm going to bring everything over to the other side. So the 2x comes over negative. The 3y is already there. I'm going to tag it along like that. Keep the sign. The 9 is negative here, comes over adding. And that's equal to 0. I can't have a negative a, so I'm going to multiply this whole thing. I'm going to go downwards like this, times negative 1. So that'd be 2x minus 3y minus 9 is equal to 0. So clean version, 2x minus 3y minus 8 is equal to 0. And then write this one, 2x minus 3y minus 9 is equal to 0. So that's the system that I would want if it asked me in general form. Okay. Let's wait a little bit there. Catch up with your notes. B. B is asking for one solution. So we're just going to make sure that slope 1 is not going to be the same as slope 2. So the first equation, I'm going to steal from the very top. I know that it's y is equal to 2/3 x minus 8/3. Therefore, my second equation will be something else. Just change it up. Make it negative. Go 4/3. I don't care. Hey, I use the same y-intercept. Doesn't matter, right? Or y is equal to negative 1/2 x plus 70. Sure, you choose. Fraction, no fraction, it's up to you. And the list goes on, right? There are a lot of ways you could write the second equation so that you have one solution. C, it says infinite. And here I'm going to do a little trick. Well, not really a trick, but I'm going to start with this one. And to get the second one, we're we're just going to multiply the top by a constant, okay, by a constant. So let's just go like this. I'm going to multiply this whole thing by 3. And so you get 3y is equal to 2x minus 8. So if you see that, I could have multiplied by negative or whatever, but there it is. Now you technically have, when you do that, you're done. You don't need to think, you don't need to rewrite or anything like that, you would be done. Or if the first one is, they gave you 2x minus 3y is equal to 8, like to begin with, to come up with your second equation, you can just multiply it by, I don't know, negative 5. Let's go times negative 5. So that'd be negative 10x plus 15y, not minus 40. That's another way of doing it, right? So if you multiply by a constant, the whole equation, you basically are coming up with a copy of it, but it just looks different, but it is still the same. So both lines will coincide. When you graph them, they coincide. Okay. All right. So that's that. I think I'm going to go over the quiz now. Let me stop this here.